outside, no need. But if you use the EI double prime equal to moment, that's the internal moment distribution inside. Okay, we are. If you use this equation, you have to write out the continuous type of loading. Then you can use this. But for this case, impossible. This part, okay. This part, for x smaller than a, the q is 0. But for x larger than a, we have this continuous loading on it. So it's difficult to write out the q. Okay? So that's the way I'm going to show you we can consider the q. Discontinuous loading. All right?
Yeah.
Now, for this problem, we do it. Okay. So for x smaller than a, my moment is like R1x, right? For x larger than a, my moment is equal to R1x minus p times x minus a. Okay. So now I can introduce define half range function with this sign. Okay. It's find this sign. X minus a. And this meaning is equal to 0 if x smaller than a. If x larger than a, that means inside here is positive, is equal to bracket x minus a. Okay? So if we define a function like this, then the moment of this problem can write as R1x minus p bracket x minus a. Okay. So one equation, this equation can handle the whole domain for x smaller than a and x larger than a. Because for x smaller than a, this term equal to 0. The only R1x will be that one. For x larger than a, this bracket, this triangle, the half range function equal to x minus a. No. So one ink for x smaller than so this single equation, I can take care of the whole domain. Then I just do integration directly to get the solution. Okay. Right. So let's do the problem again. moment is equal to minus EI. Is equal to R1x minus P x minus A. Okay? Then integration 1 is minus EI W prime equal to half R1x squared. Okay? Minus, for later on I will show you some, just like a integration, it will be half P x minus A squared. Okay? Squared. And plus integration constant A. Then I integrate once minus EI W equal to 6R1A cubic minus 6P x minus A third plus AX plus B. Okay? And we know W at 0 equal to 0, so B equal to 0. Okay? And W L equal to 0. So I will have 6R1L cubic minus 1 over 6, the P over 6 L minus A cubic plus AL equal to 0. And because L is larger than A, so this will equal to L minus A cubic. Then A equal to 1 over L P over 6 L minus A cubic minus R1 L cubic over 6. Okay. Anyway, I got A, so I put back. So my W equal to 1 over EI minus PB and R1 equal to PB over L, PB over L, 6x cubic minus 6 over P, x minus A cubic plus 1 over L, P over 6, L minus A cubic minus P B over 6L squared x. Okay. This is my A. Careful here. This term, when for x smaller than A, this term is 0. But for x larger than A, will be L minus A, just like the definition of it. So using one equation to handle, easy, huh? We don't have to consider continuity condition. Directly get a solution. So that's the beauty of this half-range function. Okay? Don't feel comfortable. Yeah, the tricky part is like, actually, So let's look at the details about how do we say. Okay. The average是吧？我礼拜都是学课那个 ，sorry。哎，怎么样？哦 ，OK， 几楼？不是在几楼？跟你讲了吗？哎 ，OK， 好，哦 ，OK， 好的。Okay, yeah. We say this is equal to 0 if x smaller than a, and equal to x minus a if x larger than a. Actually, this is equal to x minus a times Heaviside x minus a. You know this Heaviside function? Unit step function. Okay. H x minus a equal to 0 if x smaller than a equal to 1 if x larger than a. Okay. This unit step function you learned before, right? 阶梯函数. Okay? Did you learn this before? Heaviside function? No? Don't scare me. Are you sure? You didn't learn this before? No. This function, Heaviside function, smaller than a, this will be equal to 0. Larger than a equal to 1. So for x smaller than a, this will be 0. Larger than a, this equal to 1 and equal to x minus a. 可以吗？你学过吗？有学？没有。理解没有吗？会。有啊。Laplacian form 时候教过了。哦，对。讲起来了。Suppose you learn this when you learn the Laplacian form. You must have learned this before. Laplacian form, do you know? Forgot.